Hello friends, today we are going to prove cos theta plus iota sin theta raised to power n is equal to cos n theta plus iota sin n theta for all n belongs to natural numbers. To prove this, we are going to use the principle of mathematical induction. So in step 1, we are going to prove that the given statement, this is statement, you can say this is statement P. The given statement is true for n equal to 1. So we are going to take n is equal to 1. Okay. So what will be the LHS left hand side when we take n equal to 1? LHS will be equal to cos theta plus iota sin theta raised to power 1, which is nothing but cos theta plus iota sin theta. Now take the right hand side. What will that equal to? Well, that will be equal to cos of 1 times of theta plus iota sine 1 times of theta, which is nothing but cos theta plus iota sine theta. So you see that LHS is equal to RHS. Hence we can say that P, the statement P is true for n equal to 1. So you can call this statement as Pn also to denote that this is the statement for n equal to n. Now what we are going to do is doing the step second. So in the step second or step 2, we are going to assume the statement is true for n is equal to k. So assume P of k is true. It means what we are assuming is cos theta plus iota sine theta raised to power k is equal to cos of k theta plus iota sine k of theta for some k which is greater than 1. It could be any k which is greater than 1. Now in the step third, so I'm using in the step 3, we have to prove that the statement is true for k plus 1. So we have to show that to show P of k plus 1 is true, we need to show this. Now to show that, what we're going to take is cos theta plus iota sine theta raised to power k plus 1. Okay, so how can we write it? We can write it as cos theta plus iota sine theta raised to power k into cos theta plus iota sine theta. Now if you remember, what we have assumed is cos theta plus iota sine theta raised to power k is cos k theta plus iota sine k theta. So using that assumption, we can say that this term is nothing but cos k theta plus iota sine k theta. Okay, so doing that, we have some simplification like cos k theta plus iota sine k theta into cos theta plus iota sine theta. Okay, now what we are going to do is multiply these numbers and see what will we get. So we will get cos k theta into cos theta plus iota cos k theta into sine theta plus iota sine k theta into cos theta and plus iota square sine k theta into sine theta. That's what we get. Now separating the imaginary and the real part, we will get cos k theta into cos theta. Now iota square is equal to -1. So using that, we can write it as cos theta, this minus sine k theta into sine theta. So this is our real part. Now taking iota common from the imaginary part, we will get sine k theta into cos theta plus sine theta into cos k theta. Okay. Now if you have known the formulas, if you know these formulas, what is cos of a plus b? Well, that is equal to cos a cos b minus sin a sin b, and sine of a plus b is equal to sin a cos b plus sin b cos a. So if you know these formulas, or you can apply them, so what we will get is the first term, this becomes a and this becomes b, and this becomes again a and this becomes b. Similarly here, this is a, this is b, this is a, sorry, b, and this is a. Okay, so what we get is cos of k theta plus theta using these formulas plus iota sine k theta plus theta. Now you can write it as cos k plus 1 into theta plus iota sine k plus 1 into theta, and here you can write it as cos theta plus iota sine theta raised to power k plus 1. Now these two are equal, hence by principle of mathematical induction, PMI, we can say Pn is true for all n belongs to natural number, and that completes the proof. Thank you.